Okay, the next thing that we're going to do in our video is to work on some examples solving. Obviously, in calculus, we're going to have to solve equations. This, of course, is the most simple equation that we could solve. And what you're going to want to do is, there are two ways that we look at it. Sometimes we only want to find the answers between 0 and 2 pi. Sometimes we want to find all of the answers. So depending on what we're going to do, you would choose the technique that you have. A lot of times, in this set of notes, we've got here and then here. A lot of times you need to do this and then this. Sometimes you have to do this and then this. It kind of goes back and forth depending on what's going on. So for example, in this is the first thing you would recognize is, hey, this is on the unit circle. So this is not a calculator problem. This is one of the special angles that you have. And so what you're going to do is you're going to think about, well, which one this is. I always think about it in terms of reference angles first. And so I'd be like, hey, I know because it's square root of 2 over 2 that the reference angle, I'm in the pi over 4 family. The second thing that you're going to do is you're going to think about what quadrants are you going to be in. And remember that because of the all students take calculus, that technically when you look at a negative sign ratio, there's always two quadrants that you have to worry about. So, and we just talked about this in a previous example, sine is negative in quadrants 3 and in quadrant 4. So our answers, we're going to have to address the angle that's in both of those quadrants. So for A, it's pretty straightforward. I know in quadrant 3, remember it was pi plus the reference angle. So an answer is going to be pi plus pi over 4, which 4 pi over 4, remember your common denominator. And so one answer is going to be 5 pi over 4. And the other answer, if you're in quadrant 4, I'm going to do 2 pi minus pi over 4, 6 pi over 4 minus pi over 4. Sorry, not 6 pi over 4. 8 pi over 4 minus pi over 4 is 7 pi over 4. So my two answers that I would have for this basic trig equation in between 0 and 2 pi would be 5 pi over 4 and 7 pi over 4. And then if we convert this to all of the answers, that basically means take those answers and make sure you add your period or find your coterminal angles. So in this problem, you would do theta equals 5 pi over 4 plus 2 pi k, or theta equals 7 pi over 4 plus 2 pi k. Now, it does get quite a bit more complicated than that when you're solving. If you start having things in there, like I'm going to add this in as an example. What if I just change this problem slightly? And all we say is, let's solve sine of 3 theta equals negative square root of 2 over 2. This part right here actually does not change anything initially. You always kind of go, well, the angle, not theta, the angle 3 theta is going to be, now in this case, I would always do all first because you have to take into account the period. And what you need to recognize when you look at this is that this 3, remember, this is a horizontal transformation. It's actually shrinking the graph down, so it's a third of what it used to be, which means that in a periodic function, it repeats 3 times as much. So when we shrink this down, we have to take into account our period. And instead of adding 2 pi k, we are going to, because the period is smaller, it's a third of what it was, this trig function has a period of 2 pi divided by 3. So when we solve our equation, we're going to do exactly the same thing. We're going to start out and we're going to say 3 theta, okay, is going to be initially, we'll set it equal to our 5 pi over 4 plus 2 pi k. But you immediately take that and then you go, hey, I have to take into account that there was that horizontal transformation, but if you're solving, you just solve and you divide, it becomes theta equals 5 pi over 12 plus 2 pi k over 3. So you convert it to its corresponding periodic function, which has a smaller period, and you'll see that here, and then this is the angle that we're looking at. And then I would also, I'm just going to write over top here, you would do the other equation, 7 pi over 4 plus 2 pi k, and then solve that for theta, and we would get 7 pi over 12 plus 2 pi k over 3. Now, the next thing, that's all solutions, all. Then I would find between 0 and 2 pi, And what you have to do is think of 2 pi, because remember, look at your denominators, you have to think in fractions. So 2 pi with a denominator of 12 is 24 pi over 12. So obviously, yes, we're going to have 5 pi over 12 and our 7 pi over 12 as two of the answers. But remember, when you shrink it down, there are 3 repeats instead of 1 repeat. So we're going to have 3 times the number of answers. And so to basically find the rest of the answers, this would be k equal to 0. I would also put k equal to 1. And then you have to get a common denominator, so multiply by 4 over 4. So you're adding 8 pi k over 12. 8 plus 5 is 13 pi over 12. K equal to 2, you would add another 2 pi k over 3. You would have 2 times 2, 4, then multiply by 4, 16, 21 pi over 12. And notice you're still in between. And you do the same thing over here. You could also, once you start getting the period down, you know that each time you're adding 8. So 7 plus 8 is going to be 15 pi over 12. And yes, if it does simplify, but remember, arithmetic doesn't really matter. We could simplify this out and get rid of, they're both divisible by 3. So it'd be 5 pi over 4, perfectly fine as an answer. I don't know if you can see that over the blue right there. And then add 8 again, 23 pi over 12. Those are your answers between 0 and 2 pi. All right, so now let's look at another example. So solving some important things that you're going to want to review, and when you do the worksheet, there are several examples to work through to practice some of the solving that you did, but that's a little quick overview of some solving techniques. The other essential skill that we have in calculus is this idea that when you see something like this, which has a trig function tangent and an inverse trig function in it, typically when we're doing calculus, that can be very complicated. So one of the things that we'd like to do is, if possible, to eliminate the trig part of it and turn it into an algebraic expression. But essentially, this problem, as long as you understand what it's asking, is going to turn into a reference triangle problem. This is saying find the tangent ratio, so this is what I'm looking for, of an angle whose sine ratio is t squared. So we think of that as t squared over 1, because I need it to be a ratio. I know that this is opposite over hypotenuse, because it's sine, the angle whose sine is this. So when I start to draw this, now this is where you do have to worry a little bit about the principal values for the inverse functions. Sine is always either between negative pi over 2 and pi over 2. And so in that section, and t squared is always positive, which means the sine ratio is a positive number, so you know that you have to be in quadrant 1. So when I do my opposite over my hypotenuse, then I'm going to do quadrant 1 because of the SIG and the sine being positive. If I was doing cosine, your cosine principal value range was 0 to pi, and your tangent is negative pi over 2 to pi over 2. And then from there, you would kind of work with the rest of the trig functions. And then once you get to here, you're like, okay, what did I do? Remember that just like the problem we did in the previous part, you want to find the third side. So I know that x squared plus t squared squared has to equal 1 squared. That's your Pythagorean identity. So, and I'm solving for x in terms of t. So x squared equals 1 minus t to the 4th. So x equals technically plus or minus the square root of 1 minus t to the 4th, but I'm in quadrant 1, so I know that it is the positive version of that. And then the answer to the question that they've asked me here is find the tangent ratio of this angle. Here's the angle. The tangent is opposite over adjacent. So we can rewrite this with no trig functions and by doing the opposite t squared divided by the adjacent, the square root of 1 minus t to the 4th. And so this type of a problem comes up in that the calculus is easier with algebra than with trig functions, and so we just kind of convert it. So a little review of that. Right? And then the last thing that I'll talk about in this set of notes in this review set is your identities. You do need to be familiar with identities. They're just handy manipulations that we can do to trig equations, and they help you in solving, they help you in simplifying, they will help you when you are doing the calculus. Sometimes it's easier to simplify first and then do the calculus than to try to do calculus on a complicated equation. And sometimes in multiple choice, if your answer is not necessarily the answer that they have, you may need to use some trig identities to help you get there, which you should have practiced last year in trig. So you have your Pythagorean identities, your cosine squared plus sine squared is 1. These are the ones that are related to it. Just to remind you, if you take cosine squared, if you divide each of these by cosine squared, you would end up with this first one. If you divide the main Pythagorean identity by sine squared, you would end up with this one. Okay, so it's easy to remember them. And remember, you can manipulate them if cosine squared plus sine squared is 1, sine squared is 1 minus cosine squared, and so on. So just kind of review some of your trig identities. Other ones in calculus we use a lot. There are the double angles, very popular, and your power reducing, which is essentially nothing more than this double angle over here. Remember, there were 3 versions of that. If we do some Pythagorean identity substitutions, what we can come up with here, like take cosine squared out and put sine squared minus 1 minus sine squared in. Minus that sine squared, we can simplify this to 1 minus 2 sine squared x equals cosine of 2x. And then notice if I solve this for sine squared, that gives me this one. And then if you take the same identity and instead of replacing cosine squared, you replace sine squared, you would have cosine squared x minus 1 minus cosine squared x. And then when you simplify that, I'll come up, I know this is bad math, kind of all over the place, but you'll get the idea. This ends up being 2 cosine squared, because the minus is positive. 2 cosine squared x minus 1 is also cosine of 2x. And then if you solve that for cosine squared, you would get that one. So those are the ones that are probably the most useful that we do use, other than the quotient and reciprocal ones that we've already talked about. All right, so that was your quick overview of the most important things from trig, but of course you're going to need to practice. So I have given you a worksheet, review worksheet. Here's some solving. Notice here you're going to need to do some factoring over here, give you a hint. Now over here, notice you have 2 different trig functions. So I would use a Pythagorean identity here first and then factor and solve. Over here, double angle, single angle. Use the double angle identity here to substitute and then solve. Over here, again, double angle, single angle, double angle identity there. Over here, you don't have, see how here you have a double and a single? That's why you know you need to use an identity. Here, you have a triple, and that's the only one you have. So you can just go ahead and isolate and then solve using the technique I showed you earlier. Here's some practice with evaluating. Find the cosine of the angle whose sine has this ratio. Pay attention to your principal value range for sine, which is negative pi over 2 to pi over 2. Here, your principal value range for secant, I would probably convert that to the arc cosine, 1 over 3x, and then do the principal value range for arc cosine, which is 0 to pi. I guess technically this should be brackets over here too, and so on. So you'll go through, here's some identity or some graphs to kind of play around with, and a little bit of right triangle stuff and some transformations, kind of looking at this idea right here. So I'll let you kind of review, do the worksheet, and we'll come back and we'll talk a little bit more about review. You can also go and take a look at, after this video, what I would do is I would also look at the gateway test. So you have this practice right here, and then I would go back and review the gateway test for trig and see if some of the discussion that we've had here in this 3 parts of the trig review notes have helped you with some of the things that you need to do for that. And next class, we will pick up and work with the trig.